LAN Extension and Virtualization using Layer 3 protocols. It turns out there is a lot of overlap between virtualization and cloud computing. So by the time we finish all this virtualization, we have probably finished cloud computing as well. We'll have, so for clouds we need virtualization, and LAN extension is one of them. So let's see what is LAN extension. So basically we'll talk about what is LAN extension, and then today we'll talk about two protocols, TRILL and LISP, and then next time we'll talk about the rest of them, which is NVO3, VXLAN, NVGRE, STP, etc., etc. Alright, so the second protocol that we will discuss today is called LISP. Locator ID Separation Protocol. So each host has an ID and a locator. For example, my ID is here, Raj Jain, and I am located in Vashu today. Right? Last week I was located at some other place. So the ID does not change, but the locator changes. So in IPv6, you see we already have enough bits, so the first part could be locator and the last part could be ID. In IPv4, we don't have enough bits, so we have to give some number for locator, which is 32 bits right here, some address, and some 32 bits for ID. So every node has an ID and a locator. Locator is basically for the site where they are, and the ID is their ID, which does not change as long as they, whenever they move between sites or whatever, the ID does not change. So inside a site, if you are inside the site, then the routing is based upon ID. So when I am in Vashu, somebody wants to send a packet, it is done by looking at my ID. But when I get out of Vashu, then to go to wherever I am, then they will have to find out first my locator, current locator, which last week was Chennai, for example, and then they will find out how to get from here to Chennai, and packet will be delivered there, right? So that's the two parts. So the edge routers encapsulate the packet with the locator on the outer header. So basically, it's shown here. Bob is here. His ID is 1001, and the Carol is here. Her ID is 2002. Bob happens to be at this site, and it has a locator of 100,002, which is New York. Carol happens to be at Los Angeles. Her locator is 185,003. All right. So locator is where you are, and the ID is who you are, right? Now, so when a packet has to be sent from here to there, now these routers in the internet, they don't know anything about 2002. They have never seen an address like that, or 1001. So those addresses cannot be seen by these legacy routers. The core routers are legacy. They are the old routers. They don't understand LISP. They are LISP unaware, right? So the edge routers, what they do is they take the packet which was sent by Bob with the source address of 1001, the destination of 2002, and they encapsulate it, and they put the source as this New York and the destination as Los Angeles in the outer IP header. Now you can see that that packet will easily go through all the old routers and it will appear in Los Angeles somehow. In Los Angeles, this router will pick up that packet, and this knows that this is a LISP packet, so it will just open that and then send it to 2002 Carol. So how do you find a locator? That is coming up in a minute. But once you know the locator, then you can just use this encapsulation. We will be using this encapsulation thing in the rest of this lecture today, as well as tomorrow, the next lecture. Basically, tunneling is all that is about encapsulation. You take the packet and put into some other packet. So here we are using some IDs, but the IDs are not understood by the outside people, so we put them into the outside header where it is regular header, and then it will reach a destination, which is this router actually. This is the address of this router, and that router will open it up and give it the packet to the destination. So the IDs look like IP addresses, so no changes to the host. Now, this host doesn't really know that 1001, it knows that 1001 is the address assigned to it, so it thinks that this is its IP address, but it is the ID. that is the ID that remains the same. Even if Bob were to go to the other website, other site, it will have that 1001. So by the way, this is all very recently invented and all implemented now. So this is all in products. So let's see. Because the IDs look like IP addresses, there is no changes to the host. Hosts think that they are addresses and they just use it as they are given. Locators look like the IP addresses and therefore no changes to the core routers. The core routers don't know that this is something has been changed. They just use the IP header outside IP header. Changes are required only in the edge routers. The edge routers know that something is happening new. And the edge routers use IP to IP tunneling to send packets between the sites. Now the question is, how do you find the locator? So there is a map server which keeps track of ID to locator mapping. So map server. So basically there is some authority which knows where Bob is, where Carol is, where somebody is. When they move, they tell that authority. Basically you register. For example, in WashU, whenever we go any place, we have to register with WashU saying that I am going to this country. Okay? Or we tell our office person that I am going here. So similarly, you register with the map server, your location, and then your packets will be delivered there. Does that answer your question?
Yes.
Okay. All right. So now you see the header. This is your original packet, which was source and destination. Looks like source and destination IP, right? But these are IDs, and this is your IP payload. All that is put into a UDP header, and then that UDP packet is put inside the IP header. Basically the reason is, why do you need UDP? Is because you need a protocol type field here. Actually, what I have not shown here is the full IP header. All I have shown is the source and destination, but there is source, destination, protocol type, and other fields in the header, right? This is complete IP header. So here the protocol type will say this is UDP, is the payload. And then UDP will open that up and it will go from there, right? Let's see. So let's define a few more terms to completely understand this thing. First is the endpoint identifier. So the ID is called EID, endpoint identifier. And it is from a different namespace. Now, what is the namespace? Basically, when you take the addresses, that is your address space. So, for example, at my home, I take the addresses from 192.168.0.1, right? At your home, you might take it from 192.168.1.1, or some other place, 192.168.100.1, right? Everybody has a different piece of the address space that they use, right? Some places they use 172 something, some places they use 10 point something. So these are basically the address spaces. Now here, we need ID spaces. So we could take any 32-bit number space and call it our ID space. That is our namespace. Alright? And so these are not routable on global internet, because these addresses like 192 and 168, etc., private addresses, those are not allowed on the internet, right? You know that, right? Private addresses are not allowed on the internet. They are allowed inside your site but not outside. So you could use them as ID, and but you register them with your DNS. So you register that this ID belongs to Bob, this ID belongs to Carol. So when you want to talk to Carol, you go to DNS and you say, what is the address for Carol? And it says 2.0.0.2. Just like the addresses. So actually, I think you can live with the old DNS, because when you register these IDs, the DNS thinks this is an IP address. And the host thinks that this is an IP address, but this is an ID. What probably you have to change is the DSCP server. What DSCP server does is gives you the address. And it will remember that this is Bob. I got to give him 1.0.0.1 regardless of where he is. Right? So everybody gets a static IP, a static ID. for example, we have put there, but I mean, like the thing is, just think about any private space. And it doesn't, by the way, it doesn't have to be private either. It could be public too. I mean, you could use 128 point whatever it is public address. Okay, because it is not going to go outside. So here saying in my home I use 192, but it is not required in my home. I could use 128 something. It's just that with I mean, because as long as when I send out, I send it out with the correct address. Inside I can use public or private. And the reason we use private is basically so the NAT doesn't get confused. Basically the NAT knows that this is a private address and it changes it to public address and so on and so forth. But we could just use public addresses inside. Okay, NAT will have to change it to the address that the carrier has given us, because these are not seen outside. So that's the idea, that the EID come from a different namespace. They are not routable on the global internet. They may not be routable actually, and they are registered in the DNS. Routing locators are from the existing namespace. So what this is saying is these are the globally routable addresses. So locators are globally routable. So these numbers that we saw here, we took a wrong example, because these are all globally routable. This 172 number is wrong. I will have to check. I think this might be, see, thing is 172 might be okay, because some part of 172 is private and some part is public.
But you are talking about the IDs which are not routable, 1001.
Those are not routable. Those may not be routable. The thing is, but these have to be, when you have the locators, they have to be public IP addresses. So 172 is probably public IP address. Okay. Remember, there are 3 private IP addresses. Anybody remembers 3 private IP addresses? 192.168.0. I think. You have to have 168. Okay, because 167 is public. And 10 is complete available. So 10.0.0.0 is available full, 24 bits. Or with 192 you get only 16 bits, the last 16 bits. With 172 I forget. Okay, it could be, I think it is less than one. It's more than 8 bits, but less than. So it is somewhere between there. Okay, 17. So I think this is okay then. I'm not sure, but anyway, if I change that to 128, then I'm happy with everything else, because this is all public addresses. All right, in ingress tunnel router, ITR receives and decapsulates, and ETR, egress tunnel router, encapsulates and transmits. So let's look at ITR and ETR. Here, this router on the right, edge router on the right, is the ITR. This takes the packet from the outside world and decapsulates it. This is an ETR. This on the left, the router on the left is ETR, because it takes a packet and encapsulates it, sends it out. Right? So you have ETR and ITR. Now everything that is ETR is probably also ITR, because for the packets coming in this direction, it is probably going to do that. But generally when you design a protocol, you don't assume that. You assume that these are 2 different functions. ITR function is a receiving function. ETR function is sending out into the world function. They could be in the same box, they could be in different boxes. So those are the names of the functions. ITR and ETR. XTR is when you have both ITR and ETR in the same box. Map server is where the ETR register their EID prefix to RLOC mappings, and they receive the map request from the mapping systems and forward them to ETRs. So basically, these routers, the tunnel routers, they use map server to register as well as to get information. That is the directory where you go, not DNS. DNS information doesn't change, but the map server information changes as people move. Okay, so now you can see, well, let me finish this line. Map resolver receives map requests from ITR and forwards them to the mapping system. So that is basically, there are 2 functions here, server and resolver. Server is where you register, and resolver is where you find the answer. where you query. Right? So you go one place and register, you go to other place to find the answer. Now again, though both the functions could be in the same place, but these are two functions. One is a database lookup problem, one is a database entry problem. So let's see one example here first, then we apply to the data center in a minute. But anyway, so again the answer, again I took some wrong examples here. I will have to change these examples. But let's assume that this domain is dual connected. This site has two connections. One is to provider A via this router, and it has the address 10.0.0.0.8, and that address would be actually something other than 10, because you cannot have a 10 address in a public, that's a private address. Right? But let's assume that let's say this is 14 or something, okay? In that case, so this is first address, and then it also has a second router which has an address 11 something. This site has also two routers. One has with provider C and its address is 12, and with provider D its address is 13 something. Now here inside there is a person 1001 which wants to talk to 2002 here. So this is the Bob, this is Carol. So when the packet goes from here, we write a packet, IP packet, which goes from 1001 to 1002. That packet, when it reaches the exit, we arbitrarily or we, by some reason, we have to select that we have to go through provider A or provider B. There might be some policy or some reason, but anyway, for policy or reason or distance, whatever reason, you decide that we want to send it via 11, by provider B. So we take this packet, which is here, and we put the 11 header here. So it says source is 11.0.0.1 and the destination is 13.0.0.2. So we selected this source and this destination. We could have selected this source and that destination, or this source and that destination. There are many possibilities here, right? But we selected that we want to go from this side to that side by using provider B and D. So we selected this as the source and this as the destination. And now the packet can find its way in the internet, and it will appear here, right? Once it comes here, there we will take out the outer header, and then the original packet will be sent inside. Now, when you go to DNS, all DNS will tell you that the B is at 2002. So DNS doesn't really know where B is. It all knows is that the ID of B is 2002. When you go to map server says 2002 is available by two locations, either 12 or 13. At 12, the priority is 1 and weight is 50. At 13, priority is 1 and weight is 15. So basically it means that you just flip a coin and decide. It is quite possible that it could have been that the 12 has a priority 1 and this has priority 2, in which case you generally want to go by priority 1. Or the weight could be different and you want to go with the lowest weight, and so on and so forth. So each, just like in a routing table, there are weights. Has anybody seen their routing table in their computer? Right? Just say route print in your computer. And it will print out a route which has the weights and how your packets will go. So same thing here, we have the weights. So basically all this information is gotten from the map server. Actually, it is gotten from the map resolver, but the map server has the entry, and you ask the map resolver, and it tells you this. Oh, IDs have to be different. I mean, if you have people, see, look, ID is globally unique, right? Globally unique in this case means that, at least in my company, we cannot have two people have the same ID. IDs have to be unique by definition. It's like two people having the same social security number. That would be very confusing. Social security number is an ID. You cannot have two people have the same ID. Yeah, so good point. So these two people will not use the same address because they will use these IDs when are they assigned. These are belonging to the same company. So you will talk to the people who are in the same, basically those have the ID which are unique, right? I mean, in that whole domain. Okay. So originally, by the way, LISP was invented because There were several problems. Actually, probably in the next application. So I'm going to talk about this. Okay, so let's go to that. So basically, the problem was that every time you change the carrier, your address changed. So for example, if you are with AT&T, and AT&T has gotten the allocation of 128, and you connect to AT&T, they give you a number which starts with 128. And then you go to Verizon, and they are starting with 108. Then you have to renumber all your servers. Right? Because servers, people are going to reach those BEF servers, those FTP servers, and all of them. Now they will have a new IP address. When you change the carrier, IP address change, and this was a big problem. And when you have site multi-homing, that was even a bigger problem. So for example, if you had one company, two carriers, AT&T and Verizon, so you get 128 from AT&T and 108 from Verizon. Now if somebody wants to send it, they have to know that this thing has two addresses. Well, now you can do very easily with LISP, but before, everybody has to advertise, and it's kind of very difficult for AT&T to advertise Verizon's address, saying that you can also reach the same site by 108, and Verizon to advertise AT&T's address. So this was causing a lot of problems before, because people, when they moved, they had a problem, and when they're multi-homed, the other companies had a problem of advertising their location. Now with LISP, all this is gone because you don't change any of your addresses. Your these locators are basically what the rest of the world uses, and so you can go from carrier to carrier. So now, what is the application in the data center? So this was actually invented for the outside world, for the WAN traffic, but now we are using it inside the data center. Basically, what you can do is you can have two data centers, and they could use the same kind of the ID space, and then you could have a LISP aware router which talks to the aggregation switches, and then basically, so these act as the exit, and this acts as the entry here on this side. So you see, only the blue stuff here is LISP aware. These aggregation routers are LISP aware, and this XTR is LISP aware, and everything else is not aware. For example, if these core routers, they are normal IP routers, they are LISP unaware. These access could be switches or routers. If they are routers, they are LISP unaware. They don't know anything about this business going on, because they just use the internal IP addresses, and these use only external IP addresses. The core uses only external IP addresses, the access uses only internal IP addresses. It's only the aggregation routers here that know, and they encapsulate the packet when it goes out, and they decapsulate the packet when it gets in. Okay, so if you have a VM which is here, it will have an IP address. Actually, it will have an ID which will remain the same when the VM moves. You see, so we are not, now here's the thing though, this technology does not assume Ethernet at all. None of this, anything has to be Ethernet. It could be all IP with point-to-point links or whatever you want to have inside, right? So this is layer 3 technology, fully layer 3 technology, right? So you can move the VMs from one data center to another data center, but they keep the same ID, which is IP address. And notice that these IP addresses we are using just like the Ethernet addresses, where we look up the whole thing 2002, because we don't look up the prefix, because it is quite possible that 2002 is here, 2003 is over there, right? So unlike the IP prefixes, these are IDs. We look the whole thing 32 bits match. No triangulation after move. So basically what happens is that comment has to do with the mobile IP. Some of you are familiar with mobile IP. I really don't think I have time here to discuss mobile IP, but in mobile IP, what happens is you have a home agent and you have a foreign agent. So whenever somebody wants to talk to you, they talk to your home agent, your secretary first. The secretary sends the packet to you. That is called triangulation, because If it so happens that you are in France and somebody in France wants to talk to you, your secretary is in United States, they have to call United States, then it has to go back to France again, to me, or to whoever, right? So that is called triangulation, because people who want to talk are next to each other, but they have to go through somebody who is far away. Okay? That happens with mobile IP, not with this LISP. Okay, anyway, let's assume that we understand this part, that in a data center you could have aggregation switches which could act as your routers, egress and the ingress router, and this router you need because if the external traffic is coming, that has to be encapsulated so that these guys can decapsulate it. So you need one more router here. So we have 1, 2, 3, 4, 5 routers which are LISP aware. Everything else is LISP unaware. Even the VMs don't know that they are running LISP. VMs really use that as IP address, even though it is their ID. So no IP address change and no triangulation. Push or pull. Now let's see this thing. Push or pull model for resolution. So I didn't explain that part. So when you want to find out where who is, there are two ways. First is to ask, or second is to be told. So when you need something, you need to find out where 2.0.0.2 is. You could go to the resolver and say where it is. That is called pull. You're pulling the information. Push is when the resolver sends you a big table, says that look, here is the information right now. This is where everybody is. And so that could be done generally when the routers come up. When the XTR comes up, the resolver sends its whole bundle of information. That is the push. Right? Everyone understand push and pull? Push is the information is given to you, and pull is when you get the information by requesting it. Basically, when the external traffic is coming in, and let's say it is going to this VM, I don't think so external traffic, if it is going to this VM, then it will be encapsulated by whoever is sending it. Okay. Right? So it will not do anything here, it will just transmit it here. This will take it out. Yeah, so the question, actually I had in my mind the same question. The question is why this has to be XTR. This could be just a unaware router, LISP unaware totally, and that should work. This is just part of the internet. If there are some boxes, middle boxes here between the aggregation and the core, they may want to, if they want to talk to these VMs, their packet may need to be encapsulated and decapsulated. Maybe for that XTR may be used. You see, if there is a middle box here after the aggregation, it will send out a packet with only one header, and this will put another header, and this will take out that header, and finally it will be delivered here. That is one function I can think about. Yeah, so the thing is XTR will re-encapsulate the packets which are not encapsulated. I mean, there is no point in encapsulating these packets which are already encapsulated, which are coming from here.
So does it check whether it's encapsulated or not?
Well, it might. I mean, that's what it looks like, right? I'm just trying to think as to why XTR is there in the first place. But you see, packets which are coming from here, they already have dual header. And it's easy to find out whether they are encapsulated or not, because you look at the header and you see the UDP port number. Right? That tells you that there is another IP inside here. So this is for only I can see of the traffic which is not encapsulated, or so which is coming from the outside or encapsulated, something like that. So there might be some nodes here which are not inside these sites, but they still need to talk to each other. So this is my argument, is that if external traffic wants to go to this VM for whatever reason, it would say that it is 2.002, it has to be encapsulated there, because otherwise with 2.002 it cannot even come here. Right? So it will be encapsulated if it is talking to VM. The only time it will not be encapsulated is if it is talking to these middle boxes somewhere here. Right? And in that case, we really don't need XTR for that. But if somebody here wants to talk to VM then we need, so there is a middle box here which wants to talk to VM. So it needs to put another header which will be done by the XTR. So I can only think that this is how it is going, is from middle box to VM. Okay, first of all, this whole thing has only one locator. I mean, see, thing is maybe two locators at most, because there are only two egress routers. This whole thing has only two locators, right? You agree with that? Okay. So now, if you are moving inside here, you never go through locator. Now, the reason here you have to go through locator is because you are moving from here to there. Now, there are two locators on this side, two locators on this side, so you really have to do the encapsulation and decapsulation. But inside here, there is no encapsulation, decapsulation. This is like this picture here. If there is a reason for traffic to go and come back again, then you will need to do encapsulation. But if the traffic is just inside here, you don't need encapsulation. Okay. So the summary is that Ethernet is being extended to cover multiple data centers and large campuses. Networks are being flattened end to end. Most of the efforts encapsulate Ethernet frames and transport them using layer 3 protocols. TRILL uses IS to IS and the LISP uses UDP basically. And they use IP addresses. This TRILL uses MAC addresses, Ethernet addresses. So you saw two different approaches. In TRILL, we use MAC addresses as the outside header and we send it over, and in LISP we use the IP addresses in the outside header. Okay, reading list is here. In fact, there is a big reference list at the end. I don't know whether I put it in yours or not. You have this reference list. Again, as I said, reference list is not really necessary to read, but make sure that you read the reading list. Okay, all right, thank you.